Thank you, Maureen. Everyone hear me okay at the back there? Yep, gets nods. Okay, so as Maureen introduced me, I'm Brendon Slade. I'm based in San Jose, and I'm director of the horizontal enablement team in NXP's Secure Connected Edge business line. So my team looks after enablement related to software and tools that are broadly applicable across any application. And so that's why I'm involved in Zephyr as a broad-based enablement. And today I'm going to be talking about why NXP is doubling down on Zephyr, really about our experiences since the project began and why we're stepping up our resources and our engagement on the project because of how we see the market evolving. And so obviously making a gambling reference here. So am I a gambler? Well, I'm really not a gambler. I should say at this point, actually, I'm going to go back. I had some quite cool AI images that used me and David, but then turns out NXP is quite careful about things like that, and they said you can't use any AI generated images. So we've gone back to Shutterstock. So pictures you see here, you think, well, that doesn't look much like Brendon. Like this doesn't look much like me. That's why. Anyway, I'm not a gambler. I don't like gambling. I never really have. And the thought of losing lots of money that I could be spending on something else for a few moments of a thrill really doesn't appeal to me. But David, my colleague down here, he's quite different. He's a very keen poker player. And it's interesting, I talked to a few people about poker and stuff. Apparently it's very scientific these days. I always think about it in the 1970s and 80s movies growing up where it was all about steely nerve and the poker face and a bit of luck. And David tells me for him it's kind of a combination of those things. Bit of science, bit of old school. So gambling, well, I'm not a huge fan of gambling, but even someone like me can enjoy a little flutter if the odds aren't so bad. So this is a horse called Red Rum. There's a race in the UK called the Grand National that's run for many years. It's a very tough horse race with a lot of jumping, and it's very unknown who's going to win. It's a bit of a lottery, but this horse won the thing 3 times. When I was a kid in the 70s, visiting Grandma, who was a bit more of a gambler, we would have a fun Saturday morning looking at all the runners and riders, picking out the ones we thought might win. And it was always a good idea to have Red Rum. You could get Red Rum and then an outsider. You were pretty safe in an each way bet with Red Rum. Even if you didn't win, you still get some money back. So even I, as a gambling phobe, can enjoy a little gamble on something when I feel the odds are pretty good. But what has this got to do with Zephyr, you say? Well, any kind of investment by business in a project like Zephyr is a gamble. You're putting resources onto something on the belief that it's going to be a good return on investment. And so what I'm going to be talking about today is how we see the odds very much moving in the favor of investing more, and that's why we're doing that. And what exactly are we doing? So NXP was involved at the start of the Zephyr project back in 2016. And a big part of why we were doing that was some good vision from the leadership team at the time. The open source software adoption, we saw that increasing in the microcontroller market after obviously being so dominant in the microprocessor space. And it wasn't only an open source project, it was the fact that the project goals and objectives were very well aligned with NXP's. So the things have evolved somewhat since 2016, but not radically so. I think this is an extract from NXP's website looking at our strategic goals as a company, what we're trying to do. So we're trying to help companies be prepared for change. And as the market goes towards everything being aware and connected, smart, secure, and efficient, we want to make sure that our customers can leverage our products to adapt with that market. Zephyr aligns very well with a connected product market. And it also has a big focus on security and safety. So as the project's evolving, there's more and more happening with Zephyr with security and safety as well. That's continuing to evolve and align with what NXP is doing. So NXP is quite well known as automotive supplier, but we've been in the general market for a long time in many, many different application spaces with tens of thousands of customers. And we have got recently, just this year, we announced, or I wouldn't say repositioned ourselves, but we announced that there's a lot more investment in the industrial side applications now. So this again reinforces our work with Zephyr as well, and is one of the factors leading into the extra investment in that space. So in 2016, I'm going to put my glass on so I can't read my speaker notes. We came in as a platinum member, so we recognized that we needed to be committed enough to give the project a chance, right? If we didn't put enough behind it, there wouldn't be momentum, there wouldn't be critical mass to succeed. And so we did that, and we were involved in several working groups. We gradually increased the number of resources in the team over that time to do more in the technical committees and the working groups, and been contributing things like SDHC, DISC, and so on. Some of the people who've done that are here in the audience today. The team also supported NXP products. We did upstreaming the support. We saw some good contributions from others that supported some of our popular Kinetis devices, again, members in the audience who did that. And we focused on our IMX RT and LPT 5500 series devices because those were the ones most active in new designs, but we were also contributing to Kinetis parts, and even some of the IMX parts as well were happening as well. But it was more of a, I wouldn't say ad hoc, but it was more of a background of adapting to what the customers were asking for and not going across our entire product line. And we saw steadily increasing levels of interest. As there was more customers, more activity, the whole project was growing, so we saw that looking healthy and good. So that was all fine. But then there was a bit of an inflection with COVID. So suddenly, there was obviously a massive human cost, and also for industry as well. A lot of companies really struggling, going under because they just couldn't get parts. So we saw this, once things had calmed down from the craziness, companies really looking at this supply issue. It really brought that sharply into focus. There were companies paying 10, even 100 times the market price for a product which may even be a gray market product. And this really made companies rethink. They'd been relying on products from one particular chip from one vendor, and then they were really paying the price for that. So they needed to change that so that they can adapt to different devices, and then companies really scrambling. It was very, very expensive and difficult for them to do that. So there was a recognition that they really needed to be able to adapt to the situation. So the pandemic has thankfully calmed down. The supply situation is pretty much back to normal. We're seeing normal lead times for semiconductors now. So why are we still seeing companies making a switch to Zephyr? And obviously they haven't forgotten already about what happened with COVID. But we feel there's more forces at play here than just the supply issue. This is based on customers that we've worked with that have made the decision to adopt Zephyr. So my picture here is showing a showroom with a lot of different appliances, of lots of different variations. So if customers we'd seen in a place like space like the appliance market, they were using whole sets of different micros from different places, different product architectures, and focused in on trying to either there's a historical thing, there's a non-organic growth of their product line, or they just had different groups working on different projects in different places. But we're seeing them changing to want to take the same code base and apply it across different products, even products using quite low-end microcontrollers. And to do that, they need to be able to reconfigure the design very easily and move across those different platforms to move quickly without having to just throw more R&D resources at the problem. And if you're going to deliver all these products, you still have to test them, even if you can reconfigure them and build them quickly. So you have that problem to solve as well. And again, there was a lot of legacy of test infrastructure that people were having to maintain and adapt. So people quite often criticize Zephyr for being complex, right? They say, oh, if I'm from a microcontroller background, what is this device tree, this kernel config? Why do I need to know this? The build system's so complicated. Why do I need to do this, right? But what we've observed is companies have really dug into that, looked at the bigger picture benefits, and once they've got over that learning curve, they can see that the transition from one product they're developing to another one is actually much simpler, because they just have to change the device tree and modify the kernel config, and they can target another platform very, very quickly, versus with other RTOSes, which may be simpler to use, but when you change to a different underlying processor, you have to go in and refactor the code. So there's more risk in terms of breaking things, and obviously more time. And on the test side, all companies have their own test infrastructure, right? They typically grown it in the company, and they've adapted it for what they need. But the benefit of Zephyr having the infrastructure there to detect tests and to run them in a standardized way provides that for you, and you get the benefit of working with a community. So you can upgrade everything together with that community rather than having to rebuild it for your own personal usage or as you change different platforms. So we see the customers recognizing these benefits and making it a stronger case for them to adopt Zephyr. So with NXP's portfolio, we have one of our strengths is we have a very broad range of products. We have some very low-end flash-based micros up to very high-performance crossover MCUs, and then our IMX SoCs with the Cortex-A, Cortex-M cores inside. What we see is the customers want to leverage this portfolio. They don't want to have, they want to have multiple sources, multiple vendor partnerships, but not too many. So they still want to try and leverage a portfolio like this. They want to be able to make use of new technology as it comes out, either for cost reduction purposes or for introducing new features like ML. And they want to be able to make the right energy performance trade-offs. And on the IMX side, it's quite interesting that we're seeing, we've been promoting the concept of moving between IMX and IMX RT for quite some time. But we're really seeing that happening now in a couple of ways. Customers have a microprocessor-based design. For example, like in our EVSE charging solutions, we see customers having an MPU-based design, but they want to cost reduce. They want a lower-end solution, and they really want to use IMX RT for that. We see it in the appliance space as well, in smartwatches. All of these spaces where, for a combination of cost and power, they want to make that move down to the crossover MCUs. But we also see in the IMX side people wanting more performance. So they're actually going up from a 600 megahertz Cortex M7 up to a Cortex A because they need more performance. And by having a consistent strategy with our different platforms and enablement of those platforms, it makes that transition much easier. And for people my background is more on the microcontroller side, but I've heard several anecdotal conversations about Linux developers saying, oh yeah, I get this. It's much more familiar than an RTOS like ThreadX or FreeRTOS and so on. So the alignment, again, with NXP and what Zephyr brings is a very good one because Zephyr really lends itself to leveraging our portfolio. So that's a big plus for us and for our customers. Cyber resiliency laws, right? So these are right now in our faces, right? So things are changing, the legislation rules. We've seen quite slow take-up of security, to be honest. You'll see companies that are very much on it and have been for some time, and then other companies that kind of been running away screaming for quite a long time, but now they have to face it. So obviously having a strategy that is going to encompass security is important, and Zephyr has that. But one of the other aspects of this is is the longevity of support, and this is less obvious. The legislation's requiring 5 years of support or the expected lifetime of the product, which could be 10 or even more years, right? So for an OEM that's been relying on an RTOS, a commercial RTOS or another open source one, where the destiny of that RTOS is controlled by one company or is small or is proprietary, that becomes a risk. This isn't a criticism of those other RTOSs. There's some that have been out for a very long time and they have a good support model for security and long-term support. So they do exist out there, but this is one thing we see customers concerned about, that they're worried that the destiny of that RTOS company is too much out of their hands. And with the momentum and the number of companies behind Zephyr, it's a much more comfortable position to be in, to be aligned with Zephyr. So back to more of NXP's interests. So we're moving to add value beyond our silicon. So we do a lot of very clever things in our silicon, but we want to bring more value by bringing enabling technologies to customers so they can really differentiate much more quickly and effectively. So this is areas like graphics or networking or motor control and these kind of things where we can provide a lot of the building blocks that they need, which have differentiation, but not to the level that the differentiation value, multiplying effect for them is lower than if they can just focus on their high-end application. And so for us, we want to offer example integrations, say combining a motor control with a networking application. We have things like that. We have a quad motor control demo that does that over a TSN network. So we show how to integrate those pieces together, that kind of example. And as we do more and more of these, we have to pick a platform. We can't just do on all platforms all the time. That's just too much. But by building on top of Zephyr, we can much more easily adapt to a particular customer saying, oh, I love that, but I want it on this instead. So we can do that. The picture there is from our application code hub, which is a way to kind of sort through our application examples. You can filter by Zephyr. We're just starting to add Zephyr examples to this, so there aren't so many there yet, but there will be a lot more coming over the next few years. And one of the other nice things, apart from the ability to be flexible and adaptable to move to different platforms, is we don't have to give up the differentiation of our underlying hardware. So there's another talk from NXP later this week by Disha Patil, where she's going to be talking about an IMX RT 500 and power optimization on that. And that nicely illustrates how voltage scaling on that particular product can be leveraged for very low power. And it also doesn't mean that that entire project is completely locked into that device. Let's get a swig of water. Okay, so I'm going to give an example here. Now, this is a demo that we have on display this week at the Solutions Showcase. I talked about IMX RT 10XX. Well, this is an RT 1060 used in this demo. We also have done a lot of promotion at Embedded World last week about the MCX family, the MCX-N family. But they're quite different architectures. So the RT products are based on the Cortex-M7. They're based on a process that doesn't support flash, but can run a lot faster. We introduced this concept, I know, I'm trying to remember, it was about 5 years ago now, and it's done very well. Obviously, those devices rely on all off-chip, a non-volatile memory, so they have a quad SPI flash interface. They also have an SDRAM interface, which is obviously not non-volatile. And they have a lot of peripheral IP in common with IMX SoCs. And that's in contrast to the MCX-N family, which has more of a lineage from our LPC and Kinetis processors. That's where that peripheral IP comes from. It's more traditional in the sense of having a on-chip flash, has great improvements in cache and other things like that to get more performance out of the core frequency in the memory. But basically, it's that kind of lineage, that kind of device. So it runs, the core runs a lot slower. It's 150 megahertz versus 600 megahertz. but it has much lower power consumption. And the MCX-N family also has a neural processing unit as well for ML applications, obviously. So the demo that we have actually runs the same application on both of those platforms. So that handsome face is Derek Snell, who will quite happily talk you through the demo later if you want to come by the solutions showcase. So on the right-hand side, there is the RT1060 with the LCD panel mounted to it. And on the left-hand side is the MCX-N board, and that's using a quite different kind of display. The application also handles the portrait versus landscape orientation as well, and the text positioning too. So the MCX-N demo leverages the NPU hardware for faster inference times. So you can see the numbers on the screens if you squint a bit, but basically the RT1060 is running at 600 megahertz and running a ML model that's purely implemented in C. And the MCX-N is using the NPU, and our tools take the same TF-like model and compile it down to make optimal use of the NPU. But the actual source code, again, is the same. We use a binary blob that we create, and that hooks in to actually run the code on the NPU. So that's how that's different, but it's still starting from the same model. And the interfaces between all these, between the display and the camera, are very different on these two devices. So here's a high-level block diagram with the hyperlinks for the particular hardware in case you're interested in following up, looking more. So on the left-hand side, you see the RT1060 eval board, and it hooks up with MIPI CSI and I2C for the camera control. On the LCD, it has a built-in LCD interface, whereas the MCX-N, which isn't designed as much for HMI applications as the 1060 is, but it can still do a pretty decent job with the display, uses this block called FlexIO, which is like a configurable logic block, if you like, so it can do a lot of different things, including driving this kind of parallel display interface. And then on the camera side, the MCX also has another block called Smart DMA, which is useful for handling things like cameras, and the same I2C interface. So quite different hardware configurations between those two. But if we look at the actual software stack, everything from the kernel above is the same. So we're not changing any of that. All of the interfacing into the hardware is done below that kernel level. So the shim drivers, these translate an NXP proprietary SDK API, our MCExpresso SDK, for those who know our other software products, translates to the Zephyr HAL. And so this is what NXP provides, and then everything below obviously is proprietary to the different platforms, but NXP is providing all that enablement for you. So we have learned some things along the way. We did actually augment the display driver so it could handle a device which has got a lot of RAM and can handle the frame buffer easily internally. That's the 1060 versus another setup with the MCX-N where you had to break the image down into strips. But you know, it's the kind of thing you learn and you contribute back to the project. So that's what we're doing with that. But we've proven that you can make an application like this, which is quite different in terms of underlying hardware and the acceleration capabilities run on from the same code base. So I did want to mention also what we're doing around the developer experience. So we recognize that the build system and so on can be a bit confusing for people. There's a lot of different tools you need, like West and CMake and all these other things that normally people are used to installing an IDE and it's just there, right? So we know that's a bit confusing for people who maybe don't come from a Linux background. So what we've done is we introduced support for, an extension for VS Code last year, which was for general use, but we always had the intention of focusing on Zephyr and improving that developer experience. So that's what we're doing on an ongoing basis. And we, along with this, is not on the slide here, but we have an installer. So that helps you install all the different pieces you need to make life easier. And you know, we welcome any feedback on that. We're trying to keep improving it, make it better. We put quite a bit of work into our link server, which is our proprietary debugger GDB server and other utility that gives people an option along with the Sega, which J-Link is obviously very popular in the project, so we support that as well. And our area of focus going forward is how we make things easier for people who aren't so familiar with device tree, where it can be error prone when you're editing a device tree, and you can make mistakes. We're trying to figure out how we can make that better. So anyone's got any suggestions, come and chat to us. We'd love to hear about that. Nordic's done some good things in that area too, so we're watching what they're doing, interested in what people think about that. Main point though is that rather than just doing platform support, the developer experience is something we see is very important as well, and we're trying to help those people ease the transition from traditional microcontroller development. Another area that really helps is the collaboration with the projects and what that brings to the customer experience. So for us, there's a debt reduction. We don't have to spend as much time working on kind of table stakes, going back to a betting reference again, I guess, for supporting important stacks, but ones that aren't really differentiating for us or for a competition. So we can work together to generally improve the quality of things like USB and file systems and so on. But that also frees up some of the resources we would have had to put on that to focus those on developing new features that are really going to help the customer and help us make the most of the hardware capabilities that we're delivering in our products. And then community support. I think I've got a long history in applications, and customer experience is very important to me. And by having a community approach to this, rather than having people go to the NXP community, we send them to the Zephyr community and we answer the questions there, because we see the benefit to everybody of behaving in that way. So we really see that as a great way of working, and we appreciate all the Zephyr members that jump in and help each other out as well. It's a great model, and it is working, is what we see. So how is NXP doubling down? Well, we're moving from this kind of what you might call an incubator model, where we have a core team that's been doing a lot on the project for some time, but supporting platforms as they could, to one where Zephyr enablement is mainstream for us, meaning that all our new products coming out from the Secure Connected Edge business line will have Zephyr enablement as a standard thing. So when the product comes out, Zephyr enablement will be there, or will come very soon after the product launch. You've seen it with the MCX N series. We put a lot of promotion around that. We're upstreaming support for that right now. And we're working with Doulos, AC6, others to really provide that as a platform for people to get a low-cost board and be able to get started on that. But it won't just be that. We plan to do it across all our microcontrollers, apart from the very low-end ones. But even there, we're seeing customers. We didn't expect customers to want to have Zephyr enablement on the very low-end and micros, but it's happening, and we're responding to customers in that way. Greater investment engagement, that means more about our own organization getting trained up more, so our own FAEs and our own systems engineering teams, but also getting more involved in the Zephyr meetups and so on. So we're going to see us doing more and more around those things. And back in the way that we make the sausage, the way we typically work historically has been our SDKs are developed as these packages, these archive files, which when we do a release every 6 months, we generate a package like this, and everything's kind of geared around that. We're completely reworking that. So we've had SDK being pushed out onto GitHub for some time now. It's proving very popular. And we're changing things around so GitHub comes first, not last. And that's going to make everything easier to get the Zephyr enablement much faster as well. So that's happening right now. It takes some time to change the plumbing around to do that, but we're very actively working on that right now. So, and we're also going to see more downstreaming of platform support. So we're very much in favor of upstreaming. That's our fundamental approach, but we want to downstream platform support so customers can access it earlier. But I do want to emphasize we're very much in line with an upstream support model. With the IMX products, we've been doing some things a little bit more ad hoc, where different groups have looked at Zephyr and have used it for various different reasons. So we have our real-time edge software framework, which was derived from OpenIL, and we're trying to have that align with the Zephyr project, the other aspects of the Zephyr project more closely. So what RTEdge gives you is a configurable multi-core framework, so it really leverages multi-core into processor communication with a target for industrial applications, a lot of networking and motor control and things like this. So we're working hard to get that better aligned so our roadmap for IMX becomes much clearer. That's something we're working on right now. And as I mentioned in the last slide, we're investing a lot more in the developer experience, and we're very open to hear what people have to say. Okay, so all of this, coming back to the whole gambling thing, I feel pretty good about this. I'm a real Zephyr convert. I'm probably a fanboy at this stage, and I can sleep much better at night. I feel pretty comfortable with the bet we're making. So, there we go. There's my Zephyr. Dreamy of Zephyr. All right. Well, thanks everyone for your attention. I'll be in and around the different papers and the solutions section as well. Appreciate any feedback you guys might have. I hope you found this useful. The intention was to share our experiences and you know, where we're going and why we're going there. But we're keen to hear what you guys think as well, and any points we may have missed that were really critical to you. I know I didn't say a lot about safety. That's a very big thing for us as well. I didn't focus in on safety in this, but you know, that's another important area for us too. So thanks everyone. I don't know if there's any questions. Yes.
And for those watching on the live chat, you can post questions, or sorry, on the live stream, you can post questions on the chat, and I'll repeat the question to the speaker.
Okay, thank you for your presentation. So my question is, how Zephyr and your portfolio of different offerings coexist with all the rest, FreeRTOS, ThreadX, whatever?
Yeah, so it's important to note that NXP is kind of neutral when it comes to an RTOS implementation. We're not going an all-out Zephyr and nothing else, right? We are still providing free RTOS support because it is still the most popular RTOS in the market, right? But we see those as kind of parallel to each other. We do have commonality, and we have our SDK that we've always had, our proprietary SDK, but our current model is we shim that to match Zephyr. So that remains a common piece, and we continue to support free RTOS as well. When it comes to other RTOSes, we would tend to leave those to the community to support them. We have various degrees of involvement with them, but our main focus is on Zephyr enablement, free RTOS enablement.
Okay, thank you.
Still too early in the morning. Not enough coffee yet, right?
We do not have any questions in the chat, so thank you, Brendon.
All right, thanks everyone. Thank you.